Okay, so good day everyone. So today we are going to talk about the construction and building code of the Philippines. So a good day to our professor, Sir Nelson Andres, and to my colleagues. So welcome to my discussion. I am Vincent Michael G. Sauler for the course MEM 612. And let's proceed to our report. So today, here are the contents of the presentation. For the first one, we are going to tackle about the National Building Code of the Philippines, its revised implementing rules and regulations. For the second one, the National Structural Code of the Philippines, 2015, Volume 1, which will be all about the buildings, tower, and other vertical structures. So let us define the two uh, code for the structure and for the building. So the National Building Code of the Philippines aims to ensure that developers conform to the implementation of modern technical knowledge on construction, building design, occupancy, maintenance, and its use. So it is mainly focused on the occupancy, on the types of occupancy, for the maintenance of our structures here in our country. What are the appropriate methods, technical materials, and principles that we need to apply, and also the building design, the different areas, minimum and maximum required floor area for different units inside a structure. So for the NSCP, it is developed by the Association of Structural Engineers of the Philippines, or the ASEP. The NSCP is cited as a referral code of the NBC, which is the primary basis for the construction, for the design, use, and maintenance, just like the NBCP of all buildings in the Philippines. Since the latter does not specify standards for earthquake-resilient structures, the NSCP covers all buildings, towers, and other vertical structures such as poles, billboards, and other special structures, including single-family dwellings, are also required to comply with the code as a minimum whenever applicable. So it is basically all about the skeletal framework of a structure, and we also consider the seismic factor here in NSCP because our country, the Philippines, is inside the ring of fire. We are prone to different natural disasters such as earthquake, tsunami, and the like. So we indeed need the seismic factor, the safety factor, in order to encapsulate it to our design and to our analysis. So let's go to the National Building Code of the Philippines. So from the first known written building code in 1758 BC to the national building codes currently implemented in various countries globally, building codes have evolved as growing demands in the building industry arise. Nonetheless, all codes, including the National Building Code of the Philippines, have their objectives remain the same. It is to assure the wellness, so that's the primary purpose, wellness and safety of the people through responsible building design and construction. So what are the two main things that we need to consider in building an infrastructure? It is of course the safety of the people that will occupy the structure, and also if it is economical. So if the price is right, and if the price is rightful for the construction. So what is the National Building Code of the Philippines? Building codes serve as the foundation guidelines of architects, builders, developers, and engineers in designing and constructing for any safe and secure built environment. Rather than serving as legally binding and regulations, building codes serve as prototypes for legal jurisdictions to refer to when composing new statutes. And since they primarily relate to the proper planning, construction, and occupancy of buildings and structures, building codes like the National Building Code of the Philippines are also highly vital in protecting public safety, health, and general welfare. We are also protecting not only the lives inside the structure but also the public, those who are externally or outside the structure itself. The Philippines' thriving urbanization coupled with population growth made the 1970s a fluctuating era for both its economic and physical development. It became a necessity to enact Republic Number 6541, which is an act to ordain and institute a national building code of the Philippines. While RA 6541 exists to regulate the construction industry, it still does not conform to the country's developmental goals, infrastructure programs, and technological requirements at that time. The former was then replaced in 1977 by Presidential Decree 1096, more commonly known as the Official National Building Code of the Philippines, during President Marcos Sr.'s administration. All legalities were done by the now obsolete Ministry of Public Works, Transportation and Communication, and later replaced by the Department of Public Works and Highways. In its 1977 version, a huge emphasis was placed on enhancing the country's technical expertise and professional know-how both in the public and private sectors. It is obligated by the former President Ferdinand Marcos Sr. Throughout the implementation of this code, it has achieved its purpose of enforcing standardization on building requirements for their design, construction, occupancy, and maintenance. These intentions were all geared towards the general goal of building codes for securing better health, life, property, and public welfare. So that's the main goal. That's the main purpose, the vision, and the mission of our country's National Building Code of the Philippines. So, what are the contents of the NBCP? First, the permit forms. For its latest version, additional provisions were given so that each of its chapters will now have its own corresponding rules and regulations. Permit forms relevant to its implementation and enforcement were also included in the publication. However, in the entire of the IRR Section 302.3 Application for Permits, it is generally considered as the most significant architectural provision for architects. This section discusses the signing and the sealing of architectural documents to be exclusively reserved for registered and licensed architect only. This entry was established to reflect the stipulations stated in RA 9266, also known as the Architecture Act of 2004. So it is very important that when we are applying for the building permit, we go to the right professional. So for the architectural or the building permit, we can consult both the engineer, the civil engineer, and the architect, the one who designed the plan, who made the plan for a specific project or proposal. So it will both be signed and sealed by the specific professional. Both the plans, the detailed engineering design or architectural design, and also the building permit forms that needs to be complied to secure the particular permit. So next is the Fire Code of the Philippines 1977. With the Fire Code of the Philippines non-existent until 1977, signed by former President Marcos Sr., Republic Act 6541 covered provisions on fire and fire-resistive standards and discussed in Title II of the Code. While the present National Building Code enforced fire-resistive requirements, they were also applicable in construction applications, not the occupancy itself. So fire is also included for the compliance it is also a requirement for the building permit. So we need to consider some of the factors that requires fire-resistive materials in order to secure the safety and the welfare of the occupants. Number 3, the occupancy. In terms of occupancy, it was not until 2005 during the issuance of the IRR for PD 1096 when additional divisions for Group A, residential dwellings, and Group J, accessory, were declared. So provisions on parking capacity per occupancy, lot typology, easement, the setbacks that we need from the property line up to the structure, the sight lines, the right of way, which is most commonly seen in national roads, wherein we have the 20 meters right of way from or 10 meters right of way from the center line of the road up to the residential structure or commercial establishments. So we also have sidewalks, which has a common width of 1.5 meters from the pavement, and arcades were also added to its current version, all of which intricately specified on Rule 7 and Rule 8. Next is the provisions and limitations. All versions tackled different provisions and limitations concerning their allowable floor areas. For RA 6541, dwelling shall occupy no more than 90% of a corner lot and 80% of an inside lot. So you just have to get the 80% and the 90% of the total floor area of a proposed structure, all the while following the light view and easement provisions given by the Civil Code of the Philippines. For PD 1096 1977 version, the Secretary is given full jurisdiction in specifying the allowable floor areas for each occupancy, whereas included in its development controls, its IRR version provided certain formulas to use per occupancy type. And some of the examples of this aspect are the development controls include the total lot area, TLA, the percentage of site occupancy, the PSO, the TOSL or the total open space within lot, unpaved surface area or the USA, impervious surface area, maximum allowable construction area, allowable maximum building footprint area, gross floor area, total gross floor area. So this includes the open area and the closed area, allowable maximum volume of the building, AMVB, outer faces of the building, and floor and lot area ratio. So it is basically the floor area. If you have the ground floor, so it will be the second floor, it will be included for the total floor area divided by the total lot area, so that will be the FLAR. Calculations using the mentioned terms as variables were also provided for a more quantitative approach with the development controls. So next we have the exemptions for traditional indigenous family dwellings and building and public buildings. So this is for the IPs, or what we call the indigenous people. So traditional indigenous family dwellings are exempted from the following: the coverage of Republic Act 6541 to a certain degree. That is, if their construction cost per dwelling does not reach more than 5,000 pesos and is inclusively used for residential purposes of the owner and his immediate family. So that's a very important notice. While the 1977 PD 1096 exempts all traditional indigenous family dwellings regardless of their construction costs from the following provisions of the code. Their allowable construction costs to be exempted from the code also rose from 5,000 pesos to 15,000 pesos. And they are also exempted from paying building permit fees along with public building application projects. So thanks to former President Marcos Sr. And now there is a question here: is the Philippines bound for another version of the National Building Code? Well, nearing 2 decades since its latest revision in 2005, both lawmakers and experts in the industry classify the present building code as outdated and antiquated. The growing trends in the construction industry, modern urban planning, population growth, and disaster risk reduction further strengthen the concerns from both houses and the legislative branch to amend the present building code into something more in line with the country's current status in sustainability issues, infrastructure, and building technology, professional politics, among others. So most especially nowadays, we are experiencing the effects of the climate change, and also the rampant effect of earthquakes around our country is being felt. So indeed, we need to amend, we need to make some improvements for our national building codes, and it must also be encapsulated and aligned with the ISO, or the international standards, for us to further fortify our structures. So at present, 2 legislative bills were filed dealing with the strengthened implementation of the building code, albeit both with different approaches. So that's it. So the House Bill 5607, an act strengthening Presidential Decree number 1096 of the National Building Code of the Philippines, as amended by mandating a comprehensive nationwide inspection of building and imposing stiff penalties against building officials who violate the pertinent provisions of the said code. While all versions of the National Building Code of the Philippines focus on building standards throughout its design and construction process, the House Bill 5607 seeks to conduct a comprehensive nationwide inspection of all buildings in the country while imposing strict penalties for violating building officials. So we know there is some issues of corruption and bribery inside the building inside a building official's office. So we need to take immediate action and investigation for this one. And also we need to secure, of course, the safety, not the bribery notion of some building officials. So the growth of NBCP. To say that building codes are a complex body of regulations would be an understatement, as these regulations are written, rewritten, and interpreted by a legion of professionals ranging from policymakers, planners, to inspectors. Conflicting arguments along the way is part of the refinements. This is why it is important for progressive mindsets to keep an open line of communication between the public and private involved, professionals involved. Proper aptitude and disinterestedness in personal gains are essential to unravel the tangle of regulations surrounding the ever-evolving design, planning, and construction industry. So there are indeed a lot of construction system, including the integrated building system that some use, wherein these contractors use the cast-in-place method of construction. So indeed, some of them use only 10 millimeter diameter rebar for the steel reinforcement. But according to their structural analysis, it is safe and it can withstand the dead loads and the live loads that will be imposed on that structure. So indeed, there are a lot of innovations. The dynamics of construction systems that we need to consider to be included in the National Building Code of the Philippines. So now let us proceed to the National Structural Code of the Philippines. So ASEP was established in 1961 to promote the advancement of Filipino civil engineers in the field of structural engineering. The publication of the National Structural Code of the Philippines, or the NSCP, and the Referral Code of the Philippine National Building Code were published by the organization. So what is the National Structural Code of the Philippines? So let's define. The National Structural Code of the Philippines has been the primary design code that provides guidance to our civil and structural engineers on the design and evaluation, including the analysis and other structures since its first edition in 1972, which we see here in Table 1, the brief history of the NSCP. So for the first edition, we have here the National Structural Codes of the Philippines in 1972. The second one is from the 1981, third 1987, fourth 1992, fifth 2001, sixth 2010, and we have the seventh actually, which is 2015. The latest edition of the NSCP has been historically based on the UBM, or the Uniform Building Code in 1997 of the United States of America. Furthermore, UBC 1997 was the first building code that included seismic design provisions, which were significantly based on seismic data collected in the early 1990s. The code specifies that the design response spectrum to be used in the analysis was based on factors such as soil profile and seismic zone based on fault proximity. It is depending on your distance from the nearest fault line. The NSCP 2010 adopted the provisions of UBC for earthquake loadings and made 2009 IBC and ACIR, the American Concrete Institute, 318-08M as a reference. So here in the Philippines, we use various design softwares such as the STAAD Pro, wherein we analyze the building using various factors. Also the design uniform loads that we need to consider, the combined loads of the live load and the dead load, which now we are using the 1.2 dead load plus 1.6 live load. But there are a lot of combined loads equation that we need to consider, and we need to see who has the higher design load. So that will be the one we will apply to our design, structural design. And also we have design software such as the Geo5 for the geotechnical analysis, for the slope stability, for the scar depth analysis, seepage analysis, and we also have stone masonry wall analysis. So these are very important softwares that we need to be familiarized with. So the National Structural Code of the Philippines, NSCP, has been the primary code that provides guidance to civil and structural engineers for the evaluation, again, of buildings, towers, and other vertical structures around the Philippines. So it includes provision for steel, concrete, for the timber, and masonry design, as well as for estimating combined effects of dead, live, earthquake, wind, and other loads. So in other countries, they also have the snow loads. In our country, since we experience a tropical type of weather, we only consider the wind, the earthquake, the dead, the live. So that are the common loads that we need to consider. So what is the UBC? The Uniform Building Code. The last row in the table above has been added to call attention to the forthcoming update of the NSCP scheduled this year. The word, this year that this publication I referred to pertain. So the work on which has been started as early as 2007 or 2008, there was an early discussion for adopting the new International Building Code, which has since replaced the UBC in the USA. But toward the end of 2009, because of requirements that could not yet be met to be fully adopt the IBC, the code update discussions were starting to lean towards readopting the UBC 1977, particularly for the ELPs. So the International Building Code, or the IBC. So let's tackle about this particular code. The UBC 1997 is in no way an inferior code basis, particularly for the ELPs. It was in fact a major update to earlier UBC ELPs. Among the more important features of the UBC 1997 is the incorporation of near source factor, which we also adopted in our National Structural Code of the Philippines, to account near field effects, conversion of earthquake loads for use in ultimate limit states, and provision for more soil types, which involve classification according to other metrics such as shear wave velocities, as well as flagging of liquefaction prone sites. So here in the Philippines, we use the AASHTO classification, also the USCS, and many more. The UBC 1997 is actually meant only as a transition code from the old UBC ELPs. For example, in UBC 1994 to the new IBC ELPs, which are based on 1997 and EHRP recommendations. However, the initial argument that became the reason why the IBC was considered during the early code update discussion is that the IBC represents the state-of-the-art in earthquake engineering. Meanwhile, the IBC, which was initially published in 2009, has had 3 updates excluding addenda or corrections. The latest version is the IBC 2009. And to put it simply, the UBC is now an old code that has now been superseded by the newer IBC. The authors believe that updating the code means improving earthquake-resistant designs, particularly of newer structures. If the same old provisions are retained, the earthquake-resistant design of newer buildings are not improved or updated, and only the code is updated. So what are the implications of this in our country? The implications here is that if we would like to update our steel, concrete, timber, and masonry design codes, like in chapters 4 to 7 of our National Structural Code, which presumably we all desire for reasons both of safety, again, and economy, the 2 factors that is very important in proposing for the construction of a structure, we would then need to update our NSCP ELP's code basis from the UBC to the IBC. So again, the IBC effectively uses 6 parameters to define site seismicity and required level of seismic detailing, compared to 3 in the UBC. In terms of seismic parameters alone, the IBC uses 2 spectral parameters, while the UBC only uses 1, the zone factor. For specific seismic detailing requirements, the IBC effectively uses building use or occupancy, the source type, the soil type, which is very important to prevent the possibility of settlement and scouring, the 2 spectral parameters, and distance as parameters to come up with seismic design categories, whereas the UBC only uses the seismic zone parameter. So we have 2 proficient professionals we have here. That is indeed one of the foundations of UBC and IBM. So it is SK Gosh, doctor. He is a doctor. Engineer Susan Doughty, a project manager of SK Gosh Associates Incorporated in Laguna Niguel, California. While SK Josh is the president of the association, he is settling in Northbrook, Illinois. So Doughty and Gosh from 2002 state that this is one of the most significant improvement in the 2000 IBC over the 1997 UBC. The soil-modified ground motion is what a structure experiences during an earthquake. So it is only important that it should be a significant factor in determining relevant restrictions applied to a structure. It is like going from one size fits all to custom made. They continued that this is a major departure from prior practice and is reflective of real conditions. So in the case of our National Structural Code, we all know that the Philippines has been historically divided into two zones, the Zone 2 and the Zone 4, since the NSCP first edition. Our experts would have justifications for this, but meanwhile, the UBC 1997 itself assigns certain locations in the Philippines to Zone 3 and Zone 4. Recently, there are parties that still suggest that some locations in the Philippines should be in Zone 3. Actually, when we are using the Autodesk Civil 3D, especially those who are designing roads and other public work structures, we are using now the PRS 92, the CRS Coordinate Reference System of the Philippines, and it is based on the Philippine Zone 3. So that is where we base our design so that our coordinates will align with the CRS that we are using, which is the PRS 92, the Philippine Zone 3. So that our northing and easting again will be aligned. So in the Philippines, perhaps of most concern is Metro Manila, which is dissected by the Valley Fault System or the VFS, and where most economic investments, particularly in infrastructure, including the most concentration of tall buildings and urban residences, are located. We know that Metro Manila is a very high populated area because it is, of course, the capital of the Philippines. So the VFS is categorized by the NSCP 2001 as source type A, but many are stating that it could be source type B if the UBC 1997 itself was the basis. So here is an example of the spectral acceleration map of the Philippines, and I believe this map is made using the QGIS or the Quantum GIS, which most of the public sectors, particularly the DPWH, is using to make a location map, to make different maps that we need for reporting, for oral discussion, and for public consultation that we use with the IPs, with the residents, wherein they will be affected by the project. Okay. So what standard is used to construct earthquake resilient infrastructure? So builders refer to the National Structural Code of the Philippines to ensure that buildings such as high-rise condominiums can withstand tremors as high as the magnitude 8. Actually, we have here some of the news article from the Rappler. So, most destructive earthquakes to hit the Philippines since 1990, and we have here the one that occurred on July 27, a magnitude 7 earthquake that struck the Abra province, with tremors felt across the country's capital and northern Luzon. So actually, it was measured 7.3 based from the tectonic quake, but later lowered it to magnitude 7. So the NSCP lays out factors to serve as basis in designing earthquake resilient structure, seismic zoning, site characteristics, occupancy, configuration, structural system, and the height per floor. So commonly, the height from the finished floor line up to the ceiling is 2.7, 2.8, or up to 3 meters. So in an interview on November 11, ASEP Vice President Ariel Santos said The association is now working to develop a separate code for housing that would include templates for low-cost but earthquake-resilient houses. So economical, but again safe and sustainable houses or structures. The Philippine Institute of Volcanology and Seismology, or PHIVOLCS, include in 2014 a 12-point checklist for concrete hollow block houses in the country, which can be used to evaluate their vulnerability to strong quakes. So here it is. This is the 12-point checklist for earthquake safety, and this is made by the collaboration of DOST, the JICA, JST, and the ASEP. So the integrity and safety of a house depends on how it was made. So the first question we have here, who built or designed my house? So there's a checklist in here wherein you can grade your house. Actually, it's only 1 and 0. 0 if it is not applicable, and 1 if it is applicable. Number 2, how old is my house? Number 3, has my house been damaged by past earthquakes or other disasters? Number 4, we now consider the shape of the house. What is the shape of my house? So you need to check there if it is regular, if it is symmetrical, rectangular, box type, or a simple type. If it is irregular or its design is complicated. Or 3, if you're not sure, you can check out the third one if you are not familiarized with the design or the shape of your house. Number 5, has my house been extended or expanded? Number 6, are the external walls of my house 6-inch or 150 millimeter thick CHB? So some now have thinner walls, external walls. Some use only 100 mm or 4-inch. Some use 125 mm or 5 inches. So it depends, but the most safe, I think, thickness is the 150 mm thick CHB for your external walls, and for your partitions, internal partitions, we can use 100 mm. So number 7 are steel bars of standard size and spacing used in walls. So most commonly, diameter of the rebar that we use for vertical reinforcement for columns and beams are 16 mm. The stirrups are 10 mm. While for the walls, we use 10 mm or 12 mm diameter rebar. And they have a spacing which can be 250 mm or 450 mm depending on the design and the load it will carry. Number 8, are there unsupported walls more than 3 meters wide? So most commonly, the bay distance or the distance between columns is 3 meters or below. So this is to ensure the stability of the structure. So number 9, what is the gable wall of my house made of? Is it made of light materials? Is it made of concrete hollow blocks? Some in America, they use bricks, stones, etc. So what are the material used for the gable wall? So number 10, what is the foundation of my house? Is it made of reinforced concrete, steel, or stones? Number 11, what is the soil condition under my house? So you need to consult a geotechnical engineer, or you need to conduct geotechnical investigation reports for this one. They will be using the FDT, the field density test, in order to acquire the density and the moisture content of your house, of the soil beneath your house, and it will also tell you about the soil classification of the soil beneath your house. So, and number 12, what is the overall condition of your house? So for this one, we need to get the attention of the structural engineer or the civil engineer that designed your house. So for the score, 11 to 12 points The evaluation will be, though this seems safe for now, please consult experts for confirmation. For 8 to 10 points, this requires strengthening. So please consult experts. And 0 to 7 points, it is already disturbing. So you need to consult experts immediately for this one. And also we have commentary and recommendation for safer CHB houses. Okay. So what is considered earthquake resilient? So according to the ASEP president now, President Ariel Santos, buildings in the country that were designed based on NSCP must be able to withstand strong quakes ranging from magnitude 7 to 8.4. They must be properly designed, made of good quality materials, meaning standard materials, and good in construction to be considered sturdy. So, does it mean that if magnitude 7 or 8.4 happened in our country, is our structure or our house safe? Already, yes. But there is still a possibility that it will be destroyed, that it will suffer a harsh condition after the earthquake, because our code, or the National Structural Code of the Philippines, is still imperfect, and thus it needs amendment and further improvement in the future. So thank you guys for hearing my report. If you have any questions, Professor Nelson Andres and my colleagues, you can message me or you can post your questions in our Google Classroom, or you can drag your questions in our Facebook Messenger group. So thank you, and God bless everyone.